Okay, so I think we are ready now. So welcome all of you to the Wrocław JUG. I'm really happy that you all came here today. Our guest is Rustam, and I'm happy that you agreed to our invitation and you are here today with us. Everyone who watched the stream can win JetBrains license. To have a chance to do so, you just have to be active on the YouTube chat. If there will be a question, I will interrupt Rustam and ask these questions. And I hope you will all enjoy this. Rustam, stage is yours.
Thank you very much. All right. I think we can just kind of slowly get started. I'm on the chat as well. I think I should be able to see something if you are. Well, I'll say hi. I'll start with saying hi. And then feel free to ask anything. I should be able to see that as well. And also, you're more than welcome to interrupt or ask questions whenever you want. If not, then you can also, I will be able to ask them at the end as well. So, yeah, whenever you feel kind of for it. So let's get started. Today, I want to talk to you a little bit about data pipelines. And data pipelines is a kind of a very interesting topic when you have to do it, but it's very difficult to motivate and to like find really kind of cool examples to show people and to explain how things work and everything. So I was playing around and I was trying to figure out what kind of things you can do with it. And this talk is a result of this me playing around with data pipelines and trying to make it work and trying to solve some everyday problems with it. So I would like to start with this a little demo where I let me check the speakers. I'll switch to the speakers so you can actually hear, not only see but actually hear what's going on. And then let's see if we can do that. So hey Google, what's the bike availability nearby? Let's see if it works.
There are 5 bikes available at the moment. Based on historical data, the availability for this station will be decreasing for the next hour. I would suggest getting your bike within next 10 minutes.
All right, so it seems that it worked, and it's I'll switch the sound back. So yeah, it seems like it worked. And this is kind of the thing I ended up with when I was playing around with the data pipelines. And now I want to explain to you how those things actually worked and what I had to do and what is the data pipelines and kind of how you can use those in your own projects. And mostly things that work, but you can also do things like that, like fun things like that as well. So to do that, we need to rewind a little bit. So we need to go a little bit back in time and what actually was the problem that I was trying to solve when I created the whole thing. So the thing is that in Norway there is this service where you can rent bikes. I did check. I've seen them many places. So the one you see on the right, the blue ones, that's the ones that you have in Oslo. There's bikes that you can rent. You basically buy a membership for a year, and then you can just pick a bike wherever you want, and then leave it at another kind of station where you can park those, and then you can just use them as much as you want. And there's like a little bit of time restrictions and stuff like that. But apart from that, it's just you just grab one, use it, and put it back. And then you see the ones on the left. I took a picture. That must be, yeah, that was in Belgium. That's when I was at Devox Belgium. So exactly the same bicycles and exactly the same kind of idea, right? And those bicycles are everywhere. So I did Google if you had something similar as well, and I actually did find something very similar. So I think you should have something something like that nearby. And the thing is, that's usually how they market it, right? They just like, oh, it's really nice, and it's the green grass, and some water, and you're just biking, and it's really warm and nice outside, and it's very, very nice. You can just find a bicycle and go wherever you want, enjoy the summer, and things like that. And another picture of that, kind of the same thing. It's very warm, nice, and you just enjoy it. The problem is that things in Norway are. This is actually pictures. This is real marketing pictures from this public service bicycle thing, and those are really cool. But the problem is that this is how Norway is. Well, probably a bit less than half of the year. The other half, it might look like this instead. And so bicycles are kind of a little bit less tempting to use. But that's another story. Let's go back to this kind of spring and this really nice time that we're in right now, where we kind of where you just just the flowers are coming up, and the everything is getting green, and now you can actually finally bike, and all those kind of things. And so you buy this membership, you try to find a bicycle, and you look forward to actually use those. That was me I think it was a year or a little bit more than a year ago, when I was like, oh yes, this is cool. And this is how, as you remember, as I told you, this is how this normally this bicycle stands would look, or you would expect them to look like that. In reality, this is a picture I took really next to my work, just across the street. And in reality, the way they actually look is exactly the same stop. This kind of the biking place where you put them. So in reality, they look a bit more like this, and it's very, very often that the bikes are all gone, or whenever you come to a place to park your bicycle, everything is full. So it's full, and you cannot put your bicycle. And if you don't park it within some time, you'll get fines and things like that. So that kind of sucks. And then you get a bit sad, and then you get a bit kind of disappointed with the whole thing, and you kind of go back to the drawing board, and then you're like, hey, I know I can try to solve this kind of thing. I can do something about it, probably. I mean, I know IT, I know this kind of, I work with this kind of stuff, I work with data and systems and things, and I should be able to solve it. I should be able to kind of figure out what's the system of these bicycles, and how you can actually be able to get those bicycles at any time. So the kind of now I'll give you this kind of the train of thoughts that I had, and the idea was that, okay, well, there is no bicycles, that sucks. Okay, fine. Where can I actually find one? Do I know where I can find a bicycle, or where I can actually find a place to park that one? Well, I mean, the way things are right now, I don't know. I'll just have to run around the city and actually look. Can I use an app? Well, there is an official app, but that app is not really good at this kind of things. It will show you just exact position where you are, and it will show you bicycle stands near you. It will show you kind of the right now situation of the whole thing. So it will you'll see that like 5 minutes walk from your place, there are 2 bicycles available, and then while you walk and use this 5 minutes to walk, somebody else picks them up, and then there is nothing, right? So that doesn't really work. Okay, do we have a public API that I can actually access and do something about it? Well, actually they do. That's the same public API they use for the app that shows the kind of the right now picture of the whole thing. Maybe I can do something about that. Since I do not have the historical data, I need the historical data myself, and so I need to create that. Well, they do. I don't. They don't share it with us. The public API just gives you the right now picture. Okay. So how can I do it properly now? I mean, I work as a as a consultant with lots of enterprise stuff and enterprise software, and we do like data warehouses and like super fancy stuff and things for customers. So maybe I should do that. But then you realize that you don't really want your apartment to look like a server room with huge servers and computers and things just making noises and blinking at you whenever you get home. So you want to do something very compact and very kind of simple and nice thing. So what I did was the first version. At that point, I created the first version with a tiny little Raspberry Pi sitting on my desk, collecting all that data and doing some stuff with it and everything. But then the thing was that I could collect all the data, but I could not really kind of do much about it, and I had to kind of do a lot of manual work to actually see how the trends are, to draw some graphs and things like that, right? So should I write something custom, or should I go full enterprise and go totally crazy? Well, both of them are not really kind of reasonable solutions, right? So can I use something that is flexible enough that I can run on different, like my own computer, maybe in the cloud, maybe here, maybe there, different places, and it's actually open source and everything? And yeah, well, that was good. That seems like a good idea. And then I started looking, and then back then I've heard and I've been reading about this thing called Apache Beam, and then I was like, wait, that might actually work with this thing. And then I really kind of decided to give it a try. So very few words about myself before I actually explain how things were. I made these things work. So my name is Rustam. I work and live in Oslo, Norway. I work as a consultant for a company called Computas. I am also one of the Google developer experts for cloud, and I'm also a Java champion. So I work mostly with Java. I work a lot with clouds and architecture and things like that. This is kind of the things I do every day, and on kind of my spare time, I do run a Google developer group for clouds as well here in Oslo. I used to be involved a lot with the Java community and working with a lot with that, like hands-on. Now I'm a bit more doing talks and traveling to conferences and get a bit more on the other side of that. So back to our example. So the first thing that this is the first version of what I have created was this thing sitting on the Raspberry Pi on my desk, and if you look at this kind of the Lambda serverless architecture kind of thing, you end up with something like this, right? You have a cron job that will be pulling the data every so many minutes from the API, because they just give you all or nothing, so you kind of have to live with that. I decided to do it every 15 minutes. It could have been different. I went for like 4 times an hour period. So I would pull every 15 minutes all the data about all the stations in Oslo. So then I need to put it into something, right? So if the API, in my case, it provides just files, so I need to do some kind of batch processing. If at some point they start to provide more kind of streams of data, I could do some kind of streaming and things like that. But for now, I did not. They don't have that, so I would do the batch. And then I would need to put it into some kind of something that will do the traditional ETL, so extract, transform, and load. And to do that, I needed some kind of piece of software. So, well, the first kind of open source and free, easy, well, maybe not very easy, but at least available tool that you have is Apache Spark. And if you do streaming, you also have Apache Storm. And then you do some kind of magic with all this data, because it's JSON, right? So you need to do something with that JSON file. You need to convert it to something you can do some analysis on, things like that. So you would do the processing, you would do this kind of ETL job, and then you'll need to put it into some kind of data warehouse like thing. So it could be a database, it could be a bit more advanced stuff, but this is what was the first version of that, and it's okay-ish, but it requires a lot of software that is not connected with each other. It requires a lot of modifications if I want to go streams and batch processing, and all those kind of things. It's a lot of moving parts in here. So I wanted to simplify it a bit, and I wanted to do something a bit different about it. First of the things that I wanted to simplify was actually to kind of merge this stream and batch processing. Not because I had to, but more it was because it would be nice, and it's kind of the architect in me just wants to simplify it and to make it as simple as possible in case I would like to do some more stuff with it later, in case I want to add some streaming of, I don't know, say weather data, right? And things like that. So now I just want to kind of do all processing in one place, in one kind of system, and put it into a data warehouse of a kind, and then I can visualize it in a way. And visualization could be different, right? It could be graphs, but it could also be your assistant. So in this case, I just used kind of Google Home-like thing, but it could be anything, right? You can actually talk to them, and it's a different kind of user interface now, right? So the pictures and the graphs are not just the user interface that we used to know anymore. And then I realized that we have this fantastic thing called Apache Beam that is originally created by Google some time ago, and then they open sourced it, gave it away to Apache Foundation. There is a lot of big community around it. There is like really nice mailing lists where people ask things, and you can get help with things, and all those kind of things. The cool thing with Apache Beam was that it would be able to do both things. It can actually handle streams, and it can also handle batch processing in one system. Another cool thing that it has a Python and Java APIs, so you can actually use it. You can write your code. You can write your pipelines as a code in either Java or Python. And the other cool thing is that it has this a lot of built-in connectors that are readily available for you. So you can actually plug things into, for example, Cloud Data Flow to do the processing on the cloud. I'll explain a bit more about that part. But you can also attach Apache Flink. You can Spark, Apex, all those kind of things. You can attach very easily by just defining those runners and endpoints and all those kind of things. It will just handle that. So say, for example, I have, after many years of collecting this data about the bicycles, I don't know why I would do that, but let's say I do. I actually have been doing it for almost 3 years, so I'm not sure if I classify to it, if I'm allowed to say why would I do that anymore. But anyway, the thing is, so if I create lots of data and all that batch files, there are a bunch of files and I need to process them, and I want to put them on on Hadoop files or file system or whatever, things like that can be done very easily with Apache Beam without having to write all that yourself, which is very nice. And also the thing is that you can, at some point, you might want to swap the components, right? Sometimes you want to process data with some kind of on-premise solution. And now I'm kind of moving a bit more on this slide, a bit more from my own pet project to a bit more kind of real life example, because with a pet project with a little bit of data about bicycles, it's not as important. But if you have like a huge thing that your customer or your employer or whatever, whoever that would be, does not allow to move to the cloud, you want to run it on the local Hadoop cluster, that's fine. If your boss or customer or client or whatever say that they want to run it on AWS, that's fine. You can do that as well. You can do it on cloud, Google Cloud as well, and all those kind of things. You can store all those things. In addition to that, you can also plug in things from Kafka. You can plug in things from PubSub, so you can actually do the messaging. You can send the messages into the whole pipeline and process those. So that's also a very nice feature. So this is a bit more, this slide is a bit more kind of towards the real life examples than the bicycle thing. But if we go back to the bicycles thing, so this is how it looks of the architecture that I showed you earlier, but just with the real names of the things. And it's using all these kind of open source tools, right? So you have some kind of machine running Linux, whatever, server, anything that is being triggered running cron jobs. You do process files on a file system. You store files on this file system. You pick them up by using Apache Beam. Apache Beam processes those, does all the ETL thing, puts it into some kind of database, and visualizes it in, I don't know, say Jupyter notebooks or anything else, or whatever you're using for that kind of things. By the way, there is another open source tool that is not on this picture that can help you with doing the scheduling and all these other things. That is Apache Airflow. It's another Apache project that has been open sourced as well. If I remember it correctly, I might be wrong. I think it was made by Airbnb, if I remember it correctly. But anyway, so there is there is a scheduling tool, one of them anyway. There are several, bit less complicated, bit more simplified, maybe for your tooling and for whatever, for your needs. But there is a lot of ways to schedule things and to schedule running Apache Beam pipelines as well. So another thing was that I was kind of getting a bit tired of having the Raspberry Pi on my desk. Kind of the memory card died, and I had to restore the whole thing, and I lost a bunch of files and lots of data, and all those kind of things happened. So I was getting tired of all that, and then I wanted to see if I can do it managed. So I did move it to well, in this case it's Google Cloud, but it could be anything. It could be Azure, it could be Amazon, AWS, or anything else you might fancy. But the cool thing was that it would GCP, the Google Cloud, would offer me the managed version of Apache Beam. So then I just went with it. So then you have a cron job running a cloud function or something that will do the download of the files and ping the API and store it on the database, on the file system, sorry. Put it into a buckets. So we will have cloud storage where we just dump all those files to be processed. And then we use a managed version of Apache Beam, which is called Cloud Data Flow, to process all that. And then you put it into some kind of data warehouse. In this case, I used BigQuery just because I could, and it was for my amounts of data, it was free, so why not? And or nearly free. I don't remember, but I don't think it did cost me more than just a few cents. The whole setup, actually, the whole thing. And then I would just, like, if I want to visualize it or something, then I can do it in Data Lab or anything else again. So this was the kind of the cloud version of that. And now I need to now that I gave you the kind of the whole picture of how things work and what things are on a big level with all ETL jobs and a little bit of architecture and everything, I want to dive a bit into this weird thing. I mean, if you're not used to kind of the Lambda architecture, the Lambda way of doing things, and if you're not used to doing like handling with streams and all those kind of things, the whole concept of pipelines might be a bit weird. That's why I'm saying a weird thing. If you're used to that totally makes sense. When I was looking into this thing, I was still a bit not like super familiar with all this parts of it. So it took me a little bit of time to understand the whole architecture and the whole idea behind Apache Beam. And I tried to do that. So this talk is one of the ways to try to explain it in a bit different way that than they have it on the website, which is really, really nice, by the way. But I also wrote a few blog posts that I will link in a few minutes. You'll see it on the screen as well. So pipelines. What is the pipeline? Well, obviously, it's a pipeline is a think of it as a production line on a factory, right? You have like lots of bolts and screws and things in the boxes on one end, and on the other end of the pipeline, you actually have a car put together, and it's actually you can actually drive it away from the factory. So roughly, this is what pipeline is, and the definition of it is, well, it's a set of data processing elements connected in a series where the output of the element is the input of the next one. The elements in the pipeline are often executed in parallel. So you put things together in parallel, right? So some of the lines do put together only the doors, and some of the other ones put together the wheels, and then something else and something else, and at some point they just kind of merge, and then you have a whole car. So this is what it is. And the important thing here that it is a directed acyclical graph. So there are no cycles, and there is a direction. It goes only one way. You cannot just go back and kind of do things in loops. How do you do a simple pipeline? So we go from this picture of like super fancy pipes with lots of bells and whistles and everything to this pipe. So we're doing a very, very simple, super simple thing. And we do it in 4 simple steps just to get you started, to kind of get you off the kind of the ground zero here. This was the input that I needed to process. So this is the this is how it looked. So I have all the metadata about stations. So all those things that you saw where you park bikes, they're called stations, and all of them have an ID. They have and like real-time information about their availability. So how many bikes are available, how many locks are available, and some other stuff. And this was the kind of the first. I mean, there is more to that API, but for now, let's just think about that we have only this thing, right? We just have this information about the stations. We have availability, and we have a number of locks and bikes available. What I want to go from this thing, I want to go into something that I can analyze, so a table. So here, for instance, I would have something that would give me a row where I will have, so I basically denormalize the whole thing, put it into the database. I have an ID, I have number of bikes available, and I also have a timestamp, because timestamps are here important because we're collecting historical data, right? And then the pipeline. So the pipeline is works like this. So you have, in our case, we use files, but you can use some other things as well. But what I'm doing here is basically use files as an input. So JSON files similar to the one you saw earlier. I read them. I parse them line by line. I do some magic of Pardieu's. I'll explain what Pardieu is in a second, because you remember when I showed you the definition, it said that normally the things in a pipeline are being processed or happening in parallel. Well, this is the Pardieu thing. So the parallel do. So it does parse all these files and create objects, Java objects from JSON, and then I do some other stuff with it. I kind of convert it. I add timestamp to it. I change the structure of the all those kind of things, and then I put it into a database. So this is a pipeline. This is a very simple pipeline, right? So the first step is to define a pipeline. And to define a pipeline, first you will need to define options. So, and by the way, all code and everything, I'll link to that as well. Everything is on GitHub that you can actually browse through and look and see if you can do something with it, or extend it, or whatever. I'll link to that as well. But here you just define you create a pipeline options object, and you add some things into it. You add some description, you add actually default values and everything. So you create a bunch of, for example, you create a lot of getters and setters, and for all those getters that you can provide from the command line, you can also create the default values for that. So if it is not given, you can just simply use the value that is there. So as you can see, I think I should have, yeah. So the second line there, it says default string, and that's if I don't specify the file name, it will just use that file. So now that we have the options, we can create pipeline. So pipeline equals pipeline.create. And then you provide the options that you created in a previous file. Third stage is to apply transformations. This is why you really want it to, you want to use Apache Beam to begin with, right? So you do create there is this notion of P collections that they have in Apache Beam, where you create in this case, it's a key value store, where you just create, you read things from file, and then you do, in the first line, you just keep on applying things. So first apply is to read from file, and then you provide the files or file that you can read. You can also provide like with asterisk, so wildcard file names as well. Then you create some kind of function, or you call a class that will convert those JSON objects into basically JSON text into an object, and you can do something with it. And then when you're done with all those things, at the last line, you will actually write it to output. And output, and the reason I'm not saying files or database or anything, is that it can be both. And the thing that decides that basically the answer of this get metadata output method. And that one you can also change from the command line. If you just added the things like a path to a file system to store it, or some information about the database where it should store it and things like that, you can just switch it like this, and it will just keep on pushing the data to whatever you specify to be output, which is kind of cool. So you can what you can do also here, you can instead of using files and stuff like that, as I mentioned, you can use, for example, messaging stuff. You can send messages in. You can do pub/sub that you have on GCP, but you can do any kind of pub/sub like systems. You can do RabbitMQ. You can use Kafka. You can do all those kind of things. But this Pardieu thing that I have kind of mentioned already a bit, but I want to talk a bit more about that. So Pardieu is element-wise transformations, and it's actually, well, it stands for parallel do. So this is part of your system, and this is where it gets a bit weird if you're not used to that. This is a part of the system that can and have to be able to be processed in parallel. So this is nothing that you can just do that it has to be done in a specific order or whatever. So if you have hundreds of thousands of files, you can create, say, for example, hundreds of thousands of machines that will pick up one of those files and process that file and do something with it. And it should not kind of destroy the whole flow of the things. And this is the tricky part. So you always have to design the system or find these parts that are able to be processed in parallel, and then you can put them into Pardieus. So in this case, I created a transformation that does that reads from file and creates this takes the JSON strings, or strings formatted as JSON, and uses some Java libraries to convert them to objects and stuff like that. So as you can see here on next to the last line of the code, if you don't look at the brackets and stuff, you'll see there Pardieu off, and then they create this new class, a new object of the class, instance of a class called extract from JSON, and that one extracts it and does some magic with it, kind of simple magic, but still. And then the fourth stage. So when you've created all the pipeline, the options, you created all your Pardieus, you kind of thought about things you wanted to do. Now you have to run it. And running it, actually, that's another beautiful part of Apache Beam here. And that is that you can actually run the same code, the same pipeline. You can run it no matter if it is local runner or it's in a cloud. Or so Apache Beam has this concept of runners. I probably should explain a bit more about that as well. So the concept of runners is basically you write your pipeline, you write your code, but then you need to have something between your pipeline and the actual application of it. So whenever you're running on your local machine, that would be a local runner. If you're running the same thing on the cloud, you will have the data flow or cloud kind of runner thing, because you don't really want to think about the way how to implement all those things that you want to do on the cloud. You just want to run your code and you don't care. And here you can actually change that, and that's a really, really nice thing. So if you see at the second line there, I say -p direct runner. So that means that I'll be running this thing on my own machine, on my laptop, desktop, whatever I have. And so I specify a little bit of things. I specify a main class that will be starting, that where the main method is, and this is kind of the entry point of the whole thing. And I will also be specifying some kind of parameters. So in this case, I'm specifying input file. So I have just one file, just for the sake of simplicity here. And I also specify an output folder. And this is the options that I was telling you about. So you can define those options, and if you don't provide them, it will try to use the default values. This is exactly the same code without no modifications whatsoever. But here I'm running the whole thing on the cloud. So I'll go back and forth a few times with the slides, so you can actually get a chance to compare those. And in reality, you'll see that there are very few things that are different. So in the second line where it said data local runner, now it says data flow runner. So now we're doing this cloud thing. We still have main class. We still have args, but we have a few extra arguments. And those are extra arguments are kind of the cloud-specific stuff. So you provide where the buckets should be and storage and things like that, which region, which data center you run it on, all those kind of things. So going back and forth. So you see, the first thing that changes is this P data flow runner and direct runner. Oops. And then the other things are the input file are still the same. It's just the bucket now. And so GS stands for Google Storage. So it's a bucket. And then you have output, another bucket, and you have like some temporary locations and all those things like that. So this was my pipeline version number 1. So I collected all that data. I've been collecting that data since almost 2 years now, I think. Almost 2 years now, 1.5 years. I lost a little bit of data at some point when my Raspberry Pi crashed, but apart from that, I still have most of it. And that was the first idea. So I parsed all this metadata about the availability. I put it through this very simple pipeline. You see, it's just like tick, 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 just going one after another. But the thing is that this pipeline can be parallelized. So it looks like sequential, but it is sequential for one machine, but it can be run on many machines and pick up a lot of files at the same time. So the first version I did run of this thing was in September 2018, as you can see on the screen. Back at that point, I had probably 3 or 4 months worth of data. I think I started in June or April or something like that, collecting data. So back then, I had 3 or 4 months with a little bit of lost data and everything. And then I ran the whole thing. I did run this. This is a screenshot from the cloud, and I spent 18 minutes on the cloud. I did spin up 16 machines to process all that data worth of, um, I think it was like 4 months or something. So say it was 4 months, 4 times an hour, 24 hours a day. So that's how much data we have, right? One file per dump. So quite a lot of files, still quite a lot of files, but 16 machines took it in nearly 20 minutes. That was cool. And that was the output. And that was interesting, but it didn't really give me much value because I didn't know what the ID was for my stations. I would learn that maybe, but I wouldn't know what another ID of the station was and things like that, right? So the first version that I created and dumped into the database was a 1.1 million rows worth of data, and it was just 35 megs. So it was pretty much nothing. I mean, this wasn't big data or anything in any way. So now I wanted to do it a bit more advanced things, and this is also another kind of cool feature of Apache Beam that I want to show you with this thing, and that is so on the left is the one that you've seen before, right? It's availability of the bikes. On the right side, you have a metadata about one particular station. So it has like GPS coordinates, it has a name of the station, it has all those kind of things, and I wanted to combine those two. So in reality, it's two endpoints that they offer. So it's two URLs that you call. One you call to get this availability data. The other one you get all the metadata. And there is no way of kind of combining them or anything like that. So you have to do it yourself. So now I was sitting with two files, 4 times an hour, 24 hours a day for many, many months. But I needed to join them in a way. And I wanted to create something like this. So now I have the ID and I have the title, I have the subtitle, all those kind of things. I even have a GPS coordinates. I'll explain why in a second. But I had them, and why not? So now I did another run of the whole thing, and now I was sitting around with 600 megabytes of files. And this is a year later, as you can see from the timestamp. So this is 2019, end of 2019. So it's October, end of October. And now I want to load almost a little bit more than a year worth of data with 600 megs of files into the whole thing. And I also want to do this join thing. I merge two different files, data from two different files into one thing to denormalize my table even further and to have more data and more analysis to run on that, right? So the pipeline that I created, it's still very simple, but it looks a bit different and looks like this. So here you can see that I'm reading two sets of files. I'm doing two sets of processing magic. And then I group by key. So I kind of group those two together. I group them by station ID. And then I do all this parallel processing and all the other things. And at the end, I dump them into a database. Now I'm sitting here with 600 megs of files. So that's a lot of files for like just text files, right? I ended up running almost, what is that, 160, 100 and something, 100 and second see it on this. It's kind of too small. But yeah, I think I should have it there. Yeah, 160, 155 or so machines. And it took me, how long did it take me? Let me see, still 14 minutes. So it actually took me a little bit less time than the previous one, because you always have this a little bit of slowness in the beginning to do the to initialize machines and everything, all those kind of things. But the cool thing is that now the cloud would just spin up 160 machines, process the 600 megabytes, and just spin down. And in 15 minutes, I had everything processed. If I would run it on my own machine on one single core, it would probably take me quite a few, many hours. So version 2.0, I was sitting there with 1 gigabyte of processed data. So 600 megs of non-processed data for a year. Now I'm having more data. I also have this previous data and all these kind of things. And now I'm sitting with 13 million rows and 1.05 gigabytes of data. So now we're getting to a little bit of big data-ish kind of stage, right? But still, I did quite a lot of processing. I did spin up 160 machines, and I was kind of a bit concerned about the costs. And that's another thing. So if you run it on the cloud, you kind of have to think about the cost as well, because, well, it's not just your machine. It's not just your electricity bill you're paying, but it's actually might get a bit expensive. So I did see this. So I went into the console and actually had to look into this thing, and I was doing that thing in September. So and then it just said, look, for the last month, your costs increased by almost 900%. It didn't show me it did show me the price. So if you want, you can try to write the if you want to how many screens do you have? I have a lot. It's the yeah. I just saw the comments in in the chat. I do. That's the joy of working from home nowadays, right? So 900%, right? Any guesses how many euros there would be behind the black box? Anything in the chat? I'll give you a few seconds. No guesses? There is a lag, so I might not see them. 20 euros, okay? Too high. Anyone lower? It's going kind of the auction, but just the opposite way. 25? No. I said less, not 450. Okay. Let's see. Focus. Ta-da! So 3.4 euros, and that's kind of crazy, right? And this is not really. I'm not trying to advertise you for anything, and it's just to show you that on the cloud things might be actually quite cheap if you do things right. And yeah, pretty much almost. So just half of it. It's just somebody wrote that from 1 to 894, almost. But the thing is that if you do things properly in a cloud, and cloud are actually quite specialized to do this kind of things, it will spin up machines and spin down machines very easily and quickly. So you don't really have to pay much for that. So this is a price of, I don't know, a bottle of water probably in Norway. It probably is a bit cheaper in Poland, but in Norway, well, maybe a big bottle of water. Definitely not a beer. That's way more expensive. Welcome to Norway. Well, anyway, so 160 machines, 3 euros, and this is how it looks. This is how the billing looked. So I spent 3 euros on actually the processing things, and I spent 77 cents on storage, and that's kind of the 77 cents is kind of the more constant, because I just store a lot of files and I don't bother to delete them because it's so cheap. But then I spent 3 euros just to process that, and that was quite a bit of data, right? And then you get quite surprised, because then you're just like, instead of this being this sad puppy that you saw earlier, you're kind of this surprised monkey face. Well, the same facial expression anyway. You were like, oh wow, this was cheap, and that was easy. So the cool thing is that even if you don't do it on a cloud, if you just do it on your own machine, you don't really have to use all those expensive data warehouse and tools and things like that. And you can actually just run your pipeline. You can run it on your local machine. I used it a lot on my local machine to test it, so I don't deploy every time on the cloud, because there is a lag to deploy it to the cloud, to run it in the cloud. And well, obviously there is a little bit of costs, not much, but there is always a little bit. So I would always test everything on my machine, see if it works, scale it up and down, test it with different files and things like that, and then I would put it in the cloud. Actually, speaking of cloud, there is a thing I want to mention, is that it might be very, very hard to debug on the cloud. So debugging might be a bit challenging. So that's another thing. That's another reason why you might want to run it on your local machine first, and make sure that all the kind of weird corner cases are taken care of and everything. And that actually happened to me, because at some point my pipeline just broke. And it just didn't work. And whatever I tried, it would just give me this really strange errors. And then I realized that sometimes the API would have a hiccup, and it would just return an empty JSON file. So I would have empty files from time to time. And that was one of the things. But then I had to create a kind of a bit handling for that. So I had to handle that. Another thing I had to do that happened a few months later is that apparently they upgraded their backend. So now I went from kind of the minimized JSON to like compact JSON to a human readable JSON. For some really odd reason, the endpoint starting spitting out the human readable prettified JSON instead, and that broke my pipeline again. And that is actually another good thing to remember. Since we're doing things in parallel, you should expect your code to be reading line by line, one line at a time, and process it. So whenever you have prettified JSON, when it reads one line and tries to do something with it, it would fail, because it would be not a valid JSON. So that's another thing. It's kind of this, both the beauty and the other side, the backside of the medal, or call it whatever you want. But that's another thing. So parallel process, code that will be parallel processed, needs to have some kind of extra things to it. So yeah, going back to this open source version of the architecture, and this extended version where we put into this batch processing in place, I want to mention really quickly a bit about streaming. And streaming is another really cool thing, and that's also a very relevant things, because this is what we implemented so far. And if you want to go from batch processing, so files, with kind of the bounded data, to unbounded data, where you just have a lot of data just swinging by, and then you just have to kind of collect and catch and put it into the right place. And it actually can arrive at different times. It can do like it's 8 o'clock data might arrive at 8 o'clock. It might arrive at 30-ish, and it might arrive at 2:30. And then you have to kind of do a lot of things. And fortunately, with Apache Beam, you don't really have to do it yourself. You can just handle it. It will handle most of the things for you. And it can do a lot of, in a pipeline, you can do a lot of this things that you would expect to do in the streams. So transformations, we talked quite a lot about. I'm not going to talk about that again much now. But windowing, so when you do streams, you can do processing, you actually collect windows of data. You can watermark and create triggers for your data, and you can also accumulate data. So you kind of collect data and you just push it at whenever you feel for it. The way you do transformations is that you can do it in several ways. So what we did was kind of this map, more kind of a mapping way, right? We just kind of mapped the data, and you would put it in a different way and just converted it. But you can also do map reduce, so you can actually do the reduce part of it as well. And then you can also create the composite pipelines as well. Windowing, this is basically where you split the data according to some kind of thing. So it can be time, So in this case, it's time, but it can also be so it's also time, but can also be, for example, sessions. So for example, in I don't know, if you do like game development, things like that, you might not be interested in just a period of time, but you want to know that particular player did things throughout the day, and it just might happen at random times. So you can actually do, for example, by sessions and things like that. There are some cool some cool features that I really want to mention. That I mentioned some of them already, and there are a few other things that I want to mention. So one of them is the windowing. So you don't have to actually write much code about the windows and stuff.
Hey, there's a question from Łukasz. Have you tried publishing each pipeline step result as raw data to BigQuery in between steps for kind of online debugging?
It's an interesting question. No, I haven't. I have not for a few. Thank you for the question, Łukasz. So no, I have not, but that might have worked, but I'm not sure, because I mean the thing is the pipeline to put that into BigQuery, you need to create a little bit of the schema, and that raw data would require me to have, I mean, depends where you have an error, right? So if you have an error in between steps and applies, then you have to know what kind of schema your database or your data has at that point, and recreate that schema in BigQuery to push that. But for me, it would just also, what was kind of the weird thing was that the Java code would fail in a really weird and miserable way, and I would not see much in the logs. So I actually, to begin with, I actually even didn't know which step it failed on as well. So that was also another case. So you might not know always. You need to add logging and things like that. And I'll show a bit more if I have a chance in the code. But if not, then I can also I can point you to the repo, and you can look. But the point is that there you can actually give your steps names, and then you can actually see those things. And if I go back, just quickly jump back to the pipeline. So you see all those names on a ball there, and on top. Those are the names that I've given. So that's actually the things that I can call things, and I can actually know what things would be. Okay. Let me know if I did answer or did not answer your question. So feel free to ask some more stuff. So some cool features. First of them was this windowing thing that I was talking about. And you would think that you need to think a lot about, like, windows and times and things, and it's not really that. You can do it in a much easier way. You can do basically this. So you do sliding window of 5 minutes. So the window itself is a 5 minutes, and I take that window every 1 minute. Or obviously you can change those the values, but yeah, that's just to give you an idea. And that will actually give you all the events that fit that parameter. So you're kind of querying your own data, your own streams of things. Another thing you can actually do that I missed a lot, and I ended up kind of digging into the whole thing and trying to figure out how it works, and then I did share it on my blog, is that as you saw the pipeline I showed you earlier from the cloud, it has these pretty boxes and really nice names and everything. You do not have those on locally. So that sucks. And I wanted to do something about it. So I actually figured out how to, actually, I did ask on a mailing list, and I asked some people to figure out how it works. So I did get a lot of help there. But the point is, now I can dump all data of my pipeline the way Apache Beam sees it into a dot file. And then I can use some kind of visualization tool to actually create a visualization like you see up there in the corner. That is a very simple, very easy version of showing it. Obviously, you can do a lot more with it if you want to parse the dot files and do a lot of magic with it. But this is kind of thing you get out of the box, and this is what I described on the link down below there. I can probably I'll share the links in the chat in a bit. So all right. So now that we wanted to kind of go switch from files to a database, you can also do it in a very simple way. You just change the another apply. So I used to have this, as you can see on the last line here, I did text.io.write. And now I do this, I replace that with BigQuery. So in this case, it would be BigQuery, but it could have been like some kind of SQL database of any kind, or whatever you might want to use. And this is the part that I was talking about. So you need to create a little bit of schema. So that would be a bit more challenging to create this kind of stuff. If you want to do it on different steps of the different stages of the pipeline. Another cool thing is that you can actually build on more of those applies, and you can actually redirect the output to different things. So what happened was that a colleague of mine, when I showed him what I was working on, he was like, hey, I know this really cool database. If you dump the data into this database, it will be able to generate a simple map just out of the box, since you have the GPS coordinates. And I was like, okay, cool. So he spent probably like half an hour or so creating this kind of dump from BigQuery or from my data pipeline into the database, and probably another, I don't know, half an hour or so to figure out how to build this map thing. And now we just had map. Just out of the box, and just because the Apache Beam lets you kind of split the output and send it to different ways, you can actually create these things like that and dump things in parallel to a database without anyone noticing it even. And then you can do statistics, and now you can actually do a bit of statistics when you have 13 million rows, and when you have 1 gigabytes of data. And well, then now we're talking, right? Now it's actually getting a bit close to something that you can play around with. So what I did was actually did play around with it, and I wrote together with this colleague of mine. We wrote together some really crazy queries where we looked for we could calculate a number of broken bicycles by counting a number of available locks versus number of bikes available and number of locks available. So the difference, so if you sum the number of bicycles available plus the locks available, you'll get a number. So say you get 10. And the metadata about the station says that the availability of that station is 15 locks. So you can actually know that there are 5 either locks or bicycles that are broken on that station. And then you can do a lot of funny things, right? You can actually figure out how many broken things are everywhere, how many bikes are available, what are the trends. So the thing I showed you in the beginning of this talk, when it would actually calculate the trends of things, well, you can do that. And you can do all these kind of cool things. And that was fun. And that was a kind of interesting project. So I kind of recreated my own analytics studio of this, what those people have in their back office. Probably they have much more fancy version of that anyway. But I did that, and I kind of knew where I can find bicycles and when I can find bicycles in different places. And that was another kind of moment of this kind of surprised monkey kind of thing. And you were like, oh wow, this is really cool. A few warnings. I did mention a few already, but I'll mention some more. So the thing is, one that I mentioned already is that your data will change. Your data source will change at some point, and you need to be able to handle that in a kind of graceful way. So what happened with me, like empty files, this prettified version of things, a new arguments and things like that. So new properties on the objects and things like that, right? So this you will not be able to. Nothing will help you unless you actually kind of handle that yourself. The data structures will change. people don't do API management. They just do weird stuff with it, unfortunately. So like, for example, the API that I was using just went down for 3 months because it broke, and they were deploying a new version after 2 months or 1 month. I don't remember. I think it was 2 months. It came back with this prettified JSON. They didn't do any API management. They didn't do any kind of backwards compatibility thing. They just kind of, it broke, and then they just put another one. And I don't know what happened. I have no idea. But I'm missing some weeks of worth of data in between, because it would just give me 503 or 500, some kind of 500 error. Okay, there's another question from Lucas. With the data in real time, you could make Google Assistant call company that manages those bikes and tell them the station has all locks broken before they notice themselves. Yes, you can do that. And that is actually, I was thinking about doing that. And then I realized we're kind of running out of time. So feel free to stop me whenever. But the funny story, the kind of anecdote of the whole thing is that when we looked for this broken bicycles, we realized that one station had an enormous amount of them all the time. And then we realized one thing. That station was right across across the street from their the repair shop. So they have a repair shop in the middle of Oslo, where they kind of service all the bicycles and everything. So whatever happens is that all the cars that move those bicycles around, they would come and dump all those bicycles. And that's my theory anyway. They would dump all those bikes at that parking thing and lock them there until they get serviced. So that stop had an enormous amount of broken bicycles all the time. So that was kind of the bit of a comment to Lucas's comment. So yeah, and again, the Apache Beam will help you to do this kind of ETL job thing, right? You still need to do all this analytics, and you need to decide where to put it into database, and how do you want to play with it, and what do you want to do with it. But that's up to you. But you don't really have to put it into database even. You can even put it on a pub sub as a message on a message queue, and pop them up on the screens or whatever, do a lot of fun things with it. Your imagination is kind of just the one that kind of sets the borders, the limits here. So yeah, this is the architecture I ended up with. This is the architecture I'm running right now, and it seems to be working pretty well, and it's actually quite fun. The whole kind of my pet project that I'm kind of playing from time to time whenever I have time, you'll probably see it on commits. They're kind of very strange times when it's committed, and very kind of irregular times. But the whole idea was to play around and learn Apache Beam. So if you want to do that, you're more than welcome to do that. I'll also post that link as well in the chat in a second. Whenever I can actually copy paste things, I'll put it in the chat there. And you can play around with it and do that. So this is it, what I have on slides, but I'll be more than happy to chat and to talk, and to, like, if you have any questions or comments or anything. If not, you can find me on Twitter. This is my Twitter handle there. So find me, follow me. So it's R and then my last name. So R for Rustam and Mehmandarov. And then you can shoot me an email, and my blog is there at the bottom there as well. So this is, again, my lastname.com, and you will find a blog there. So I have a few blog posts there that I'll be linking in a second there. So while I'm doing that, type some questions and ask some things, and I will, yeah. So this is the first. So this is the kind of the version, the link I posted there now is the blog version of the talk, how to build a simple pipeline in 4 steps. And then I have another one where I do this pull the graph representation of the pipeline and visualize it. So that's that one. And I do have a lot of other things, mostly Java stuff on that blog. So have a look around whenever you see something interesting. I did a few posts about microprofile. I really want to write another one because I called that one part 1. So there'll probably be part 2 at some point whenever I get to this magic time called vacation. I'll probably do some writing then. And the repository is here. And one last link. That is me on Twitter. So feel free to.
Hey Rustam, where are you
Yes.
sharing the links, on the Twitter or on the comments on
It's
the?
coming on. It's on comments on YouTube. I'll share it properly in some other way, but there is a lag probably on the chat, so you don't see them. I don't know. Can you see any links?
For now, no, but it's no problem. We will share this on the Twitter, so it's no
Perfect.
problem.
Yep.
Just send me, you know.
Yep, I will do that. I'll do that.
Okay. In the, I thank you for. We thank you as a JUG Wrocław for coming here. We are really glad that you agreed, and we hope that someday you will come physically to the Wrocław and make some other talk, and we will spend time together.
Thank you very much. I would love to. I haven't been to Wrocław yet. I've been to Krakow quite a few times. I've been to J Santa.
Yes, J Santa last year.
That's where we met, right?
Yeah, exactly. Yeah.
I was at J Santa, and I did stop by in Warsaw a few times, but that's kind of a layover at the airport, so that doesn't count. So, but I would love to come to Wrocław. That would be. I really hope that all this virus thing will go away soon, and we can actually do it in person at some point. It's kind of cool to see familiar faces, by the way. So, Piotr, nice to see you. And yes, I agree. Piotr says, pity it wasn't real. I agree. I also would love to have it in person. That would be really, really nice. I can share my slides as well, but I usually don't like doing that because I think my slides usually don't make sense without me speaking. But if you want to do that, I can do. If you want me to do that, I'll do that because I usually keep it very simple and lots of pictures and little content, little text.
We can just share the whole YouTube presentation, right? Just the link.
Yeah.
So it's more information from that will be. Yeah.
So the links I posted links to you in StreamYard chat as well, and then you can just you can distribute them in a way you want. Oh, okay, they get. I'll send them over to you again because I see that the StreamYard did something with the formatting, but that's fine. I'll fix it.
Yeah, no problem.
So, any other questions? Oh, there is a question. Perfect. Lucas is really, really active. I really like that. That's really nice. Are all those parts of GCP on your chart native to Google Cloud, or did you have to install some of the frameworks on bare VMs? Kind of PaaS versus SaaS and versus EIS question for that example. No, they are all native. So what I used. If we go back to that, and well, I mean, again, this is GCP, right? If you would have run it on other clouds, you might need to install some of it. So, for example, I'm not aware of any other clouds that provide Apache Beam out of the box managed. So you might need to install that in a way. If if I haven't seen any yet. I've seen talks doing it, but usually they kind of ended up on installing things themselves, I think. So that is the only thing that is that works on GCP, but might not work out of the box on the other clouds. But the other things, cloud functions, well, you have every cloud providers have cloud functions, right? Serverless. Cloud storage, well, all of them have. It's a kind of buckets, storages, whatever they call them in the cloud that you might use. PubSub, also the same thing, messaging. All cloud providers have some kind of way of messaging, so persistent kind of message queues. Well, Dataflow we talked about. A data warehouse solutions, most of the cloud providers, again, have it in one way or another. It could be a database, it could be a data kind of data warehouse, it could be anything. And visualization things, well, most of them support Jupyter notebooks and things like that, so you can do very simple visualizations. But then you have Power BI, for example, on Azure that will be even much more powerful than anything else to visualize things and everything. It's kind of similar to Data Lab, but probably a bit more bells and whistles in it. So your mileage may vary. I picked a cloud that I kind of work mostly with, and I don't really want that's not my point to kind of promote any specific clouds to you. But my idea is to actually to explain and to show you how Apache Beam works and how you can get started with that. So great to hear that. It's good that GCP takes part of the maintenance from the developer with that setup. Yes, they do. So here you just run your code and you just, as I showed you, you just switch one parameter when you run it from your own command line, and it just deploys it to the cloud and everything. Obviously, you need to set up some authentication, and you have to have you'll see it on my GitHub, but there you can actually see the how I did it. But then you just need authentication file, and it will just deploy it to the cloud immediately. So that's a very nice thing. That's kind of the thing that I wanted to do, to take it away from the Raspberry Pi on my table, on my desk. Thank you very much for lots of great questions, Lucas. That's really nice, and the rest of you as well, Piotr, and all of you really. So, any other questions? Anything else that you might want to ask? Did the links appear on the chat, or they kind of got taken away by the spam filter? And
I think they didn't come because of the spam filter.
No, yeah, probably spam filter does not really like sharing lots of links. So we'll post the links in a few minutes, I guess, or very soon. And again, I mean, feel free to ping me on the social media. Email probably counts as social media as well. So, that's also another way of communicating, I guess. Thank you very much as well. Thank you for all for coming and for listening. And I really hope to see you again. And I hope to see you hopefully in real life as well.
Okay. Thank you. So thank you, everyone. Thank you, Rustam. Bye.
Thank you.